In this video, we are learning new differentiation formulas. Specifically, we want to see derivative of trig functions. There are 6 trig functions: sine, cosine, tangent, cotangent, secant, and cosecant. So we have their derivative respectively here. One thing we notice is derivative of any trig that start with the C, cosine, cotangent, cosecant, there's a negative sign in the result. This would help remembering those formulas better. Also, I want to comment on the notation, like a secant square. This represents square of the whole secant, just like it here. This is actually the third part of the whole cosine. But for convenience, when we write those powers, we usually put the power here instead of outside parentheses. But later on, when we differentiate those guys, we like to write it clearly in the form of a power, as you'll see later when we introduce different rules, differentiation rules. All right, so these are the new formulas, and it's pretty straightforward. So we're going to just see how to apply those formulas to differentiate more complicated functions, functions involving not only powers of x, including radical, but also maybe trig. The rules, differentiation rules, will be the same. We're just adding more formulas. So whenever we see trig, we'll be able to find the derivative. All right, so let's see some examples. All right, so first the function we want to see is x squared times cosine x. And this is a product. As we see, it's a square times a trig. So it is a product. Now, this is a product rule. We are applying product rule to find the derivative. Like applying any rule, we should always try to first set up the answer according to exactly the formula here. Okay, so in this product, this will be like a F, this will be like a G, all right? So let's apply formula. So y prime equal to, first again, like I said, set up just like the formula here. So it's going to be F prime times G, which is cosine, plus F times G prime. This is to ensure that we're applying the rule correctly. Okay, so we're basically still in the stage of learning these basic rules. We need to slow down, make sure we're doing it right. Once we make sure the rules apply correctly, then we move on to complete the problem, take care of specific differentiations, like here derivative of x squared, and we learn it's a 2x. Just bring 2 down, reduce power by 1, and the derivative of cosine, and that's new. That's one of the formulas we have available derivative cosine here, negative sign. So we do now apply formula here. And that's the answer. Okay, so it's pretty straightforward. Just approach the problem in the same exact way. First, see what kind of function we are dealing with. In this case, it's a product. So we know, okay, this is product rule. And then once we started, we are going to first set up the result exactly like what the rule says, product rule. And then later steps, we finish up the details, the derivative of specific thing. Okay, so I'd like to see that you always set up your expression correctly first. All right, let's see next one. Next one is sine x times cosine. Again, it's a product. So we're going to apply the same product rule. In this case, sine is like f, cosine is like a g. Okay, so we will apply the product rule. Like I said, set it up first. So it's going to be f prime times g plus f times g prime. Right now, well, of course, it's important to do this. Like I emphasized, just to ensure we're doing it right, even though it's a simple. There is a more important reason we are doing it like this, setting up first. Reason is later on we're going to see products that are much more complicated than just simply x squared times cosine or sine times cosine. Could be a very complicated thing times another very complicated thing. So we will have to slow down. So we don't need to take care of many different things at one time. All right, so slow down. All right, so we set up our result according to exactly the rule, you know, f prime times g plus f times g prime, like this, and continue to finish all the differentiation. So derivative sine, well, it's another formula we are learning. Derivative sine is cosine. So we have cosine x times cosine x. And derivative cosine is a negative sign. We apply formula x up here. So this will be the answer. You don't have to simplify. But if it's not much trouble, it's always better to simplify. Okay, so this is better. This is acceptable. Okay, let's see more example. So this one here again is a product. Square x times secant multiplication. So we're going to apply product rule. Before we do that, let's rewrite square root as a power. So this is rewriting. So I'm going to use the equal sign to continue. This is the same as the original. Now it's clearly a product of two things we can differentiate. All right, it's a product. So let's start to differentiate. As we start to differentiate, we start a new line with y prime leading the identity. So y prime equal to, again, set up first, no rush. X to half power prime, x half power is f times g plus x to half power times the g prime. So f prime times g plus f times g prime. Set it up like the formula here. And then you finish up the differentiation. First is the power. So we differentiate power by bring down the power half and then reduce the power by 1. Subtract 1 from 1/2 times secant. And well, this is new. Derivative secant, we check our formula. Derivative secant is a secant times tangent. So we're going to have actually two tricks. It's a secant x times tangent x. All right. And finally, let's see derivative of tangent over x squared plus 1. This obviously is a fraction, so we're going to use quotient rule. Remember quotient rule? F prime g minus f g prime minus over g squared. So there's no need to rewrite anything. It's ready, so we'll go ahead and differentiate, starting with y prime equal to, first we're going to have the g squared, so it's x squared plus 1 squared g squared. Set up. Tangent is f, so this is f, this is g. So we're going to have f prime first, so tangent prime times the bottom g minus tangent times the g prime x squared plus 1 prime. Again, set up the expression based on exactly the formula. Now finish up the differentiation. There's no differentiation in the denominator, so we just copy down the square of x squared plus 1. On the top, derivative tangent, use the formula, it's a secant square. Derivative tangent is secant square. Here. All right, and times x squared plus 1 minus, remember it's minus, tangent times, now derivative of x squared plus 1 is a 2x plus 0, so it's just have a 2x. This is the answer. Okay, so this is how we apply the new formulas to differentiate functions that could involve these trig functions. Okay, let's stop here.